Bismillahirrahmanirrahim. Today we'll discuss the optimal control, and optimal control is basically the advanced form of the control in the modern. It is considered as the modern control, considering the classical control as the output feedback control, and where you have the loops going from output to input, and you are just trying to directly directly control the output, comparing with some reference. So optimal control is an advanced form of the control, and in which we are considering some specific performance criteria rather than the typical performance criteria, which is based upon the transient response or the steady state response and error constant. And in the optimal control, we are more concerned. Uh, Basically, we focus on the performance criteria which are more realistic compared to those reshaping the compared to the ones where we try to reshape the transient response or try to modify the steady state behavior. Here we try to define the performance in terms of the states, or the overall convergence of states, or the control of the control energy, or control energy is basically the expenditure incurred during a process. So in the optimal control, we actually try to define the performance of the system in terms of more realistic parameter rather than in terms of overshoot and damping ratio, or the transient response, or the settling time. So, in optimal control, we try to first we try to formulate the performance index, and just like in uh, chapter 5, we said we defined some performance indices like IAE, integral of absolute of error, or we said integral of time absolute of error, or integral of squared of error, and or integral of time squared of error, like this. These are just error based performance criteria, error and time based. But a more realistic performance criteria is how fast, or how much the state is diverging from the reference in the overall process, or another performance criteria is how much control energy is being used during certain process. Or I can define the performance if I define the performance in terms of deviation from the final desired value. So it depends upon situation how I define my performance index. So in optimal control, this is basically modern control technique, and it is based upon more realistic performance criteria, more realistic performance. My years. So suppose I have an simple operators. Just to give you some examples, I have a simple operators of inverted pendulum. inverted pendulum. What will be the performance criteria for me? Probably I want the pendulum to be vertical very quickly, and I want the cart to be around certain positions. Suppose this is the inverted pendulum, this is the length of the rail where the cart is, this is the end point of the rail, and here it is cart, and a pendulum is mounted on this cart. So my cart should not go out of these bounds,